So yesterday, wait, is this thing working? Yeah, okay, I think it's streaming now. Yesterday, I basically dug myself a nice deep hole by trying to implement junctions in a way that didn't work. So let me. This guy's important. Okay. So let me look at the git diff here. What did I do yesterday? Because some of this stuff I want to keep and some of it needs to go. So this thing labeled dumb, I will get rid of. So first thing I'm going to do is change gates to use the same port structures that the gates in the future components use. So I did this change here to have Gord and Jordan. I think this is fine. Also, I think it's funny, so I'm going to keep that. This is okay. That I just have this for debugging. This is actually okay. This is questionable, the way that I updated DFS, and I haven't even tested this. I don't know if it works. Yeah. What to do about DFS? Let's take a few seconds to think about what we need from DFS. The only place where we use it right now is in erase square. And if we erase anything but a junction, so okay, no, hold on. We only call it DFS in erase square when we erase a net. Except we have to do that too when we erase a junction, because a junction is basically a net. So okay, let's break it up into two cases. Case one, we erase a junction. Then we just perform DFS as normal on all the four neighbors and create nets from all four. So in that case, actually, I think we need to do the same thing whether or not we erase a junction or a wire. In both cases, we scan all four neighbors and build nets out of all four. So when we do a DFS, we do need it to traverse junctions. So when we hit a junction, we should convert that junction, or we should look up what net we hit when we touch that junction to see if it's the right one. Because, for example, it's possible to have a junction next to a net that isn't connected to it. I'm not sure why you would do that, but we do need to support it. And so we'll check the junction, and now here's what's tricky about it. When we do okay, I think I see what has to happen. So for, let me go over to DFS here. Where is it? Oh, this is the wrong, it's in here. So when we're in DFS, what do we do? Oh, wow. Okay. So I actually have it specifically checking, I'm asking the question, anything connected to this net. And where's the recursive call here? It's right here. So I think we do need to do a recursive call on DFS when we hit a junction. Well, yeah, actually, I think what happens is if we, so let me just write this in as an idea. I won't implement it quite yet. Idea, if grid of L is a junction, just set I don't know if that'll work. Ugh. No wonder the junctions have been so difficult to implement. Hold on, I'm just checking something here. Yeah, okay. I think we need to rethink DFS. I think we need to rethink it, like from scratch. If grid, okay, so let's not do it here. So what happens here? If grid of the neighbor is a net, then we add that linear coordinate to our list of coordinates. We mark it as seen, and then we do DFS based on that spot. At no point inside DFS do we actually check the type of the thing. Well, actually, we do check it here. Right, so I guess we do need to write this special junction logic in the neighbors. So if the neighbor is a junction, what do I have written right now? I add it to the list of junctions. But the problem is here, Control P. Actually, do I really even need to make this a to-do? I think it's enough to just do. I think it's enough to just do this, right? Keep searching for neighbors starting from the junction square. And notice that when we do a recursive call here, we give it the same end that we've been using the whole time. I think that might actually be enough. So if I go in here, so I added this case. Don't mark gate. Well, let me fix this comment. Don't mark. No, we do want to mark it as seen. Yeah. If O.net is equal to n, assert n.j of O. Wait, what am I checking here? Yeah. This is right. Yeah. So we may as well just stick this in for now. It'll help us. Yeah, I think this is actually okay. I think this is actually okay. And we will also add O.net. I know, not O.net. O.parent.c. We need to add the coordinate as well. So add this to the list of junctions found by DFS. also add this coordinate as part of the net. And then keep searching for neighbors starting from the junction square. That might actually be good. That might actually fix it. Okay, now, what else? In the post condition, we added this check here for port. This will have to get changed when I change the, actually, so will this. Yeah. Here in draw grid, I must have added a special case. I did, okay, I do have a special case for junction. And we can keep that actually, that's fine. Of course, this nets will change to, well, we can keep calling it nets even if the objects have type port. No, maybe we should call it ports. Hold on, where are we using that? Okay, hold on. It's getting hard to see what's going on here. Man, how much more do I have to? This is like undoing. It's like you broke a vase and you're gluing the pieces back together. Like I just spread a whole bunch of crap everywhere and now I'm doing surgery to fix it. I think I fixed DFS. I think that's okay. All displaced component stuff in Gordon, Jordan, those are fine. This JNumLet is going to change because I'm going to change this. Instead of using string keys inside the nets, we're just going to use the same old port numbers that Gates used, and we'll make them port objects because that will make it possible to use the same code path in certain cases, maybe. Then in draw G menu, that's okay, that's good. Here we go, place wire. If C and or P are junctions, decay them to the relevant net. Local D, do the LWL dot LWL minus L. So this is going to change to PNumLet, and we'll make it or 1 because we have to pick one of them. It doesn't really matter which one. Like in other words, if it's not actually a neighbor, then it doesn't matter which net we choose. Then inside place wire, I changed this to unassert. Well, whatever. Add all of C's junctions to P. That does need to happen. I don't know how this right bracket got in there. Oh, I guess I moved this LWL up in the function. Yeah, I did. Yeah, for convenience. Okay. Oh boy. Okay, so here's this new stuff I added. I think when we place a junction, oh no, this is in function array square. Oh yeah, actually, that's a neat little hack there. Yeah. I think that actually does work. this change to place gate is fine. This, okay, now this place junction needs to be changed because I'm changing this to be like proper port objects, and I'll call this ports even though like we all know it's nets, and I'll change this instead of R to be 1, 2, 3, and 4 like with the ports. Okay, so oh yeah. Oh my goodness. I'm looking at these things that I have added in, and it's like, oh man, this is gonna be tough. Oh, these are really tough to fix. But okay. So first thing is get rid of this dumb, this dumb Janum LUT. Just get out of here. We're getting rid of that. Over here where we create a new junction table, we are now going to do this. We can keep the direction. That's kind of neat. And we'll do type equals port. Can I get away with doing this on one line? Yeah, I can. I don't even really need the direction, but type is going to be equal to port. We're also going to rename it ports. Now, I'm calling this net instead of neighbor. Should I call it neighbor? No, I shouldn't. It really doesn't make sense to call it neighbor, like from the point of view of, even if I didn't have gates, it still wouldn't make sense to call this neighbor. It isn't the neighbor, it's the net that it connects to, so. And then here, local nets, we can call this j.ports, even though that's a little weird. So nets of 2, nets, 1 and 3. I sure hope this is going to be worth it. So now this nets of left. I think I did this. in a weird way. Let's do it like this. 4, 3. Okay, and then j dot. I don't need to do j dot. I can just do nets 1 and 2, and add nr.j j1 j2. What is this nr? Oh yeah, junctions. Now, do we add the junction or do we add the port object? In the gates list, we add the port object, and that makes sense because let's add the port object. I may regret that, but I think it's okay. This also will imply changes in all the other places where I did stuff, so. Okay, now, Control F this Janum LUT and get it out of here, just out. Local Pinum. It's going to be Pinum LUT 1, and then here it is now. given did I just dig myself a deeper hole? I dug a hole at the bottom of my hole. Is it possible that if I actually made it have the word neighbor, like NBR, instead of net, that I could use the gate? Wait, oh no, this is the... no, actually this is fine. It needs to be a separate case anyway here. So, bam, 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 and bam. This is fine. Now, did I do that case if junction parent at the end there? Oh my god. Where are my notes? Where did I put that? One sec. Okay. I've probably spent more time just on this junctions problem now than like any other part of this project. In place wire, we always add current to previous, and if they're both nets, excuse me, current is merged into previous and then deleted. If current is a net from a junction, then we need to edit the junction to point to the new merged net. Okay. So, add all of C's junctions to P. Make sure the net pointers are updated. Well, wait a second. Am I right in thinking that this will take care of making the junction point to the new net? So add all of C's junctions to P. So for each J in pair C dot J, there's my little log message, but I do P dot J, J equals true, J dot net equals P. Actually, that takes care of that. So actually, I don't need this. I don't need this thing here. I don't need that at all. So yeah, that might take care of that. All right, what else? Let me go back up to the top here. So that's okay, that's okay, that's okay. DFS, I think we fixed it, although we do need to edit it now to use the right variable names. DFS if grid is junction. Oh yeah, here we go. Penum. Okay, so we did that. Okay, let's go fix the post condition. What line is that? Oh, right. Okay, this is the line number of not the line of the tab, the line of the whole P8 file that has all the tabs concatenated to each other with some metadata here and there. Else if type equals port. Oh, I called it ports. Or I called it port. It should be port, not ports. Now I gotta fix. Well, it should be enough to just Control F for ports and just fix them all. Where else did I do that? Oops. Okay. Okay. Maybe that's it then. So what was I doing? Oh yeah, the post condition. I was fixing the post condition. So for P in pairs n dot G, for G in pairs of gates, check all the ports. That's fine. Oh, we don't have a post condition for junctions. So actually this is okay. Let me just put that in as a to-do. Okay. Now inside draw grid, I just need to change this. Yeah. So yeah, right here. So port 1. Port 2. Okay. Okay. Now what? That's okay. Oh boy. And then place wire. So this is going to change. Oh wait, I think I already did that actually. Yeah, I did already do that. Let's just Control F this for JNum. Okay, good. JPUM. This should be PNUM. Get out of here. Okay. Now, erasing square. If C dot type is junction, what is C here? This is in erase square. What's the keyboard shortcut? Oh, here we go. It's Alt up and down. So we go down here. So what is C? C is the grid of L, right? Yeah, okay. I could have been more consistent with my variable names, but, well, you know. So if it is a junction, then we remove it from the list of junctions. Okay, this needs to change. C dot port 0. Oh, suddenly I have J here for some reason. C dot port 1.net. Assert it is not blank. It should never be blank. Grid of. Oh yeah, so this is my hack to correctly deal with rebuilding the nets. It's pretty ugly, and this led to an infinite recursion, by the way. Not 0 and 1, it should be 1 and 2. Oh boy. Oh, this should return. That actually might be why I had this issue. Maybe. No. That would be why I had infinite recursion. But it was wrong to not have a return. I really should just make this an else, even though it means I'll have to indent like 1,000 lines of code here. I think it is more logical. Get in there. I am sure that I have some hideous syntax error now, like some misbalanced, unbalanced, you know. Actually, I think it's fine. Okay, now place gate, this is all fine. Place junction, that actually is fine. Well, we will need to fix this though. So, erase square, place junction. So, oh wait, I did fix that, didn't I? It was the first thing I fixed. Yeah, okay, this is actually fixed. Then this is fine. And then that is actually still relevant. Also, let me fix these spaces though. Not that I think it matters, but it's a little bit hard to tell if it's a tab or a space. In fact, it's impossible to tell. Okay. Alright, let's see if we have any syntax errors. Oh, that's surprising that we don't. Let's see if we broke it. In other words, if we broke something that was previously working. I don't expect to have fixed anything that was previously failing. I have it on button P right now for the sake of debugging. Oh, I think I need one more. Okay, well, at least that's still working, which is nice. All right, here we go. Let's see what happens when we place a junction. So connecting wires to junctions, I don't think is implemented. You get a runtime error. What was the error? Attempt to index local j a number value. Oh boy. For j in pairs, c dot j. What was c? I think if I do resume, I can read the log. Oh, well, cannot resume dead coroutine. Okay. So we need to figure out what's going on here. What are we placing inside? So let's look here for add. Star J. Do I need to do dot star? Is this proper regex? I think it is. Needed to escape that. So that is correct. What about this? Yeah, that actually is correct too. Oh, wait, but is it correct in my edited version? Okay, I think, I hope this works in Minty. Let me Control Z this. Oh, you can't. Well, too bad, it's gone. Now we're gonna look at the current div. And let's search for that same string. So that's fine. This is fine. Okay, so why attempt to index local j, a number value? How is this a number? Oh, wait, I just did add, didn't I? I don't want to do add. What am I doing? That's not what I should be doing. I'm using a set. I'm using a set, so add nr.j. So this, I don't know what I was thinking here. nr.j nets 1 is true. Hear the dog barking. It actually barks very, very seldom. It's pretty unusual. Oh yeah, add jo. What function is that in? Let me just search for it. Whoops. Ah. I keep using the scroll wheel. DFS, okay. So this actually should be J. Oh, wait a minute. What is J here? Oh, that's actually fine. Yeah. This is actually fine. So when we're add all of C's gates and add all of C's junctions. Yeah, this is fine. Okay, now if we place a junction, if we try to wire something to it, this isn't, oh my goodness, we get this bizarre result. Okay, I need to do something with the log here. I just want to do a quick, really dumb, where is that? If button P of right on controller 1, then we will just log separator. Actually, I don't want to use equals because I'm already using that, so let's put some stars. No, I don't like that either. What do we have on, oh, actually, this is fine, like that. Okay, let's look at this again. So let me, oops, put in the junction. Actually, create new net. While you're on blank, create new net. Nothing else. Yeah, okay. So now, if I do this, what the heck, man? Like, what happened there? Merge previous and current. I need to try that again. I didn't catch it. Component, put in a junction. Let's add in some wires, and then before we do this case, let's put our separator, and now let's place it. Now we get this bizarre circumstance here I haven't figured out why that happens. Wire on wire, that is actually correct. Merge previous and cur, that is actually correct. I think that's correct. Or at least that's intended. Merge previous and current. If C does not equal P, then we do all of this. For each of C's coordinates, edit them in the... Whoa. Let's just dump some logs here. Log C dot C coord. I'll just do C dot C equals L divided by, oh, yeah, this is GW and L mod GW. Okay, grid of LL equals P, P dot C of LL equals true. Let's start with that. I think these two cases are pretty much going to be okay, but let's do that. So we will place a junction, place a, no, oh my goodness, okay, start again. Place a junction, place a wire, let's put in our separator and go. We get this weird situation. C dot C equals 391. Actually, where's my debug for the nets? Did I get rid of that? That would actually be helpful now. I think I kept it. I think it's just commented out. Let's make that a function. I think it's somewhere in here. I know I kept it. So, kabam. Function dump nets. Kabam. Yeah, I think that's all we need. So let's just go in here and we'll put it after the post conditions, I guess. Dump nets. Let's try this. So put in a junction, put in a wire, put in a wire. Now, if I go in here, one net? What? How come there's only one net? There should be more than one net. Okay, let's start by fixing that. Control F, no. Erase square, place gate, place junction. Oh, I guess I just never added these. No, I did. I did add them. There's only one net. That is just not right. Let's fix this first. So if I just place a junction like that, no nets, that is not correct. Why don't we have any nets? What? Okay. Log. I should really add this log into my debug.p8. It's actually been pretty helpful. Anyway, for size of nets equals size of nets, and then after let's place a component. It went from 4 to 6. How come this has num nets equals 0? Like, what the heck? What? Okay, we really have to figure this out. Something's messed up. So here's my idea. What we're gonna do is noisy is equal to new index equals function of tkv. We will do log setting k to v raw set t av index. Actually, that's all we need. That's all I care about right now. What? What? Oh, I'll bet you add calls raw set behind the scenes, which is why my noisy thing didn't work. I don't understand how number of nets is 4 in that function, but it's 0 here. Like, what? Is there a raw len? Oh, there is. Attempt to compare a number with nil. In draw line number 235. Actually, maybe I just don't know what raw len does. T equals 1, 2, 3, 4. I probably don't want to do that. Y equals 1, 2, 3, 4. The length of y is 4. The raw len of y is also 4. How come this didn't work? Oh. Well, first of all, this should be here, for one thing. I don't know what was wrong with that before. Now, what I don't understand is why the log isn't getting called. It should be getting called on every frame, which I knew would happen. I knew that would happen, but why is it not getting called? Do I just not understand how to use meta tables? Is that what's going on here? Okay, let's give up on that, because it didn't work. And let's just put it in here. Let's try calling dump nets right here. Oh, it's only going to be there for a single frame. Because it uses debug, doesn't it? Well, if I put it in frame by frame mode, this is actually something I've wondered. How can you pass inputs in frame by frame mode? Go 8. Okay, well, okay, we will just do high pairs nets. Oh, duh, oh my god, duh, no wonder. I'll just say ends. Alright, that explains a lot. That also explains nets 1. No wonder I was getting something at number 1. I have no idea what was going on with number 2 and 3, but anyway. Oh, no. Alright. So, let's place a junction. Hey! Oh yeah, okay. We don't that's right. The post condition doesn't understand junctions yet. So let's fix that. It'll help. Then schedule, it could be a junction, so we'll do if grid of C dot type equals junction. No, let's do it like this. If grid dot C does not equal N, or grid dot C dot type is junction, and grid dot port 1 dot net does not equal N, and grid dot port 2 dot net does not equal N. If all of these conditions hold, then the grid is wrong. Oops, what did I do? Oh. Okay, so let's place a junction. Still says the grid is wrong. Oh, hey, how come this is pointing to 1? That doesn't make sense, right? You see that? Net 1 has just grid coordinate 1, so I think something is wrong in our nets that we create. C equals L. What's L? L equals CY times GW plus CX. That seems right. Oh, wait a minute. Oh. Wow. I know. L equals true. Okay. I think we're finally starting to fix things now. This is starting to be fun again. Well, it was always fun, but when things are broken and you feel like it's slipping out of your control, it can be a little, well, you know how it is. I think we all know how it is. All right. Moment of truth. Well, at least the coordinate looks right, but it is still complaining about the grid, so we'll have to fix that. Numnets equals 2. Yeah. Okay. So we can get rid of that before and after there. Don't need this. Let's try and fix this again. So if grid C type equals junction, so, oh no, I think this needs to be an and. Yeah, actually. So wait, no, this still doesn't work. When do we throw this? No, this was right before. It was right before. What am I doing? So if oh, I get it. If grid of C dot type does not equal junction and okay. Oh boy. Grid dot port 1 dot net does not equal N. grid of C. Don't know how that happened. Okay, we're getting there. Okay, great. No post conditions. The nets look mostly correct. All right. Now, let's try and fix that other problem we were having. It might actually get fixed for free. Okay, let's put in a separator now in our log. Okay, we have a separator. Now let's do this. And the junction just vanishes, which is a little strange. Oh boy. Net 1 points to 522, but grid wrong. Oh, we just straight up replaced the grid square. I mean, so I'm not debugging the junctions yet, but actually this is correct. That net 2 right there is correct. Actually, the net 1 is correct as well. So actually, that thing that I deleted, I actually need to not delete that. So, local parent junction is false. Parent junction equals C. So now here, where we are placing wire, it's in the wire-on-wire case, and we have a P as net type, merge previous and cur, so this is correct. It's wait a minute. Wait. Merge previous and cur, right? For each of C's coords, add them in the grid to point to P. Oh my god. Grid of LL. Oh my god. Oh. Are we gonna? Shoot. I mean, there's a hack that comes to mind. Okay. There is a hack that comes to mind. Hack. Because the for loop for the nets clobbered all the grid squares, replace the junctions. Now that is hideous. That is hideous. Grid of j dot c equals j. Let's also put this here. I mean, I think it'll work though. Almost. Oh yeah, j dot parent dot c equals j dot parent. Oops. Okay, what happened? Merge previous and current. I think this is actually correct. We have no post conditions. Okay, I think we just need to edit the draw function to understand having a junction as a neighbor. So draw grid. Check all the neighbors. If the neighbor is equal to O, else if it's a gate. Actually, I think we can just do this. Ah, darn. Why didn't that work? Oh, neighbor. Shoot. Fine. We will do it the uglier way because that is what we're doing. Actually, I mean, this is also ugly, but, you know, stop. What did I do? Okay. For torpedum.net equals O. I should try to fix that. Try to fix this ugly neighbor net thing. Also, I wrote 0 there, but I meant O. Alright. Hey! Now. Oh, look at that. I mean, we still have, let's not, get too overconfident here because we still need to fix, actually we may have done this, maybe, but we definitely still have these two problems which are really quite tricky. Okay. Actually, come on. It's so annoying when I have it in this button P mode. That's a little too fast, but whatever. Oh, okay, maybe not whatever, because it's too fast to see. I really need, okay, oh my goodness, oh my goodness. Okay, I tried to erase something and everything died, so, oh man. I think we're finally making progress on this stupid thing, but it is very slow. Fix problems with erasing and DFS. Oh man. What happened this time? Oh, because I erased a wire because I placed a gate over it. I just want to try this one stupid thing. Hey, would you look at that? Okay, so we've definitely made progress. This is definitely progress. But we have to fix the erasing. All right, let's find ourselves a smaller test case for erasing. Okay, no bad post conditions. Only one net though. Now, why do you suppose that is? What do we have in the log? Nothing. Am I even logging anything from this erase square? I guess I don't need this return. Oh, okay, I guess I don't need this return, nor this one. That wouldn't fix anything though. Okay, this is just bothering me. Just get it out of here. I'll save it in my old debug stuff. Somewhere in erase square. Ugh. Remove this coordinate from the net and clear the grid too. Remove the net from the net's list. The remaining portions will be re-added. Oh, because of the DFS. If grid local neighbor equals grid L plus D if neighbor is a junction, decay it to the underlying net. Type equals junction, then local pnum equal to pnum of if neighbor dot port pnum dot net equals C, then C equals neighbor dot port. Fine. Well, no, whatever. Neighbor dot port of pnum dot net. Now, what else do we use C for in this function? Oh no. I want neighbor. And now we will do if neighbor equals C. Yeah. Okay. That should help a little. It won't fix everything, I don't think. Let's connect this. Now let's erase it. Now, we still have two nets. Oh, God. Found neighbor. I mean, at least that's correct. Also, I want to get rid of that printout. Where is that printout? I don't need this anymore. It's just a pain. So if I do this, I have two nets. Now, I connect it to a wire. Now two nets. 1, 2, 3, 4, 5. There should be 5 elements in there. How come there aren't 5 elements in there? And in particular, I noticed that 519 is only part of net 1, but not part of net 2. So, why? So the thing that just happened was merge previous and current. Also, this wire on blank is just, well, yeah, we don't need wire on blank because we already have create new wire. So wire on blank. We already have the two cases spelled out. Okay. Component junction wire, get in there now. The problem is that net2 should have 389 listed in it, but it doesn't. So under merge previous and cur, for each of C's coords, edit them in the grid to point to P. Wait, what? Whoa. Did I delete that? Oh, duh, okay. I shouldn't have deleted everything. But yeah, let's still get rid of this wire on blank. It's not giving us anything helpful. Okay, now we do this, connect the wire to it, check the log, and well, the nets are fine. 519, 520. Now, if I erase this, now what do we have? So net 2 is still messed up. Why? Why? This is the case where we do the DFS. Ugh. Okay, let's quickly, before I lose my mind here, Ooh, okay, so we definitely have a infinite recursion problem. But anyway, before I lose my mind, let's commit this to GitLab. Git add dash u and git commit dash m. I don't know what to put in here. I'll call it proof of life on junctions. This should help me with debugging if I can take diffs relative to this point. Let's push it, why not? Yeah. I'm starting to lose focus. It's really tough to do this kind of coding after I've done a whole day at work. Plus, I still need to make something to have for dinner. I've actually been planning to make a recipe I saw online, and I bought all the ingredients for it, and I just haven't made it for like, I think almost a week, maybe even over a week. I think the ingredients should still be good. Let me just, now that it's on my mind, I gotta check. Yes, they are all still good. Thing is, with me, whenever I do a recipe the first time, it takes like 3 times longer than it should. And it's getting late. This is why I haven't made it yet, because it's like, you know. But maybe I'll make it tonight. It's an easy recipe. Anyway, enough of that. Enough of that discussion. Let's go back to coding. So we have a couple of problems. Let's start by fixing this first one, where when we erase the wire, I think I just need to put some more log statements. So after found neighbor, run DFS and create new net from result. Now, the way I've edited DFS, whether or not it works is a different story, but the way I've edited DFS, this R should have the coordinate from the junction. Let's do 2 things. First of all, let's make this a bit bigger. 64, why not? And also, let's go in here into erase square and do, I just want to add like a thing that'll prevent it from looping indefinitely. So D for depth. D equals D or 0. If D is greater than, I don't know, 100, then log infinite recursion. just what we need to do is in the call to erase square, we will just call it with d plus 1, d plus 1, okay? Now let's put in some more statements. Let's start with DFS. Trying to think. So let's do log DFS at keep doing that. L mod GW L floor division GW So let's do log neighbor, and let's also just do this to make it a bit easier to read. Neighbor of D, and I will just understand how to read D. Well, we can do penum. Why not? I mean, there's no reason to make it harder to read. Neighbor penum is junction. And this actually should be in here. Log junction connected, keep DFSing. What did I do? Oh. All right. Okay. Now if I erase, oh my goodness. Oh, okay. This should just be port, not ports. I don't know why we weren't getting that before. That's a little weird, but. Oh, well, I think that's the problem we were having before. Net 1 points. Okay, hold on. Let me do a cleaner test case there that I know what's going on. So let's actually put the junction at 0, 0. Connect the net like that. So net 1, net 2, that is correct. Everything's fine so far. Now if I go in here and erase that. So net 2 is incorrectly has no coordinates in it. DFS at 0. DFS at 0. And it just doesn't do anything? Oh, I see. I see. I see. I see. There's probably like a more elegant way to code the DFS so I don't need this case up here. But whatever. You know, not everything has to be elegant. I mean, it's better if it is, but you know, else if grid of L dot type. But if we do a DFS on a junction, then there's no. We don't know which direction we connected from. We don't know which direction we erased from. Oh man, oh man, oh man. Now that is ugly. That is ugly. Okay, there's another way we can encode this logic though. Instead of doing it in DFS, we can do it in erase square. So here where we iterate through the neighbors. No, but wait, no, I am doing this. I am decaying it to the underlying net, which is exactly what I should be doing. Except when I do DFS, oh, I see. So when I decay it to a net, and then I run DFS, so that is actually working, but okay. I had an idea, but I just realized that it's not that nice. Well, because we can. No, I mean, there's no way this is the right solution. But it would work, though. It would work. And then here what we'll do is nothing, actually. Put a junction connected by a wire. Erase that wire. Okay, actually, wait a second. But this is the case that I thought I fixed when that like unforgivable hack that I did. We do DFS, make a new net from R and returned gates junctions. Whoops. Returned gates junctions. Blah. Let's also do this. For JJ in all JJ in all JP do NN dot J of JJ equal to true, and then JJ. Oh, but this is not returning. For the gates, it returns the port object, right? Oh yeah, okay. Yeah, okay, we're also doing the same thing there. Good. JJ dot net equals NN, the new net. So that's something that we had to do. I don't think it's going to fix this problem that we were just having, though. Who overwrote that grid square? Who did that? Oh, we need that same dirty hack right here. Need the dirty hack because the nets loop clobbered the junctions, put them back on the grid. I really don't like that, but I mean, can you think of a better solution? Like, I don't know. What we need here is grid of JJ dot parent dot C equals JJ dot parent. It still doesn't work. And if I check the post conditions, same thing. Although now at least the nets are correct. It's just that. Now how come this didn't work though? Oh, I know why. Okay. So this. absolute mess. I think, whoops, too far. I think the problem I'm dealing with here needs to be solved inside DFS. I think my original idea is still going to be better. If not C, then add C of L. Yeah. Else if grid of L type equals junction, then if grid of L dot port 0 dot net equals n, then add okay, actually I got a better idea. I know I don't have a better idea. Wait, no, I do have a better idea. For P in grid L dot port do if P dot net is equal to n, then some stuff, and then we'll break at the end of this. So if it is equal to n, we will do add CL, and we will also do add, I think we need a case for junctions, for gates too. Or do we? Wait. Wait. Oh, but if I erase the net right next to a gate, then we go into DFS, and the type of n, so then we check all the neighbors, but the, wait a second, I think this problem exists for gates too, and I just never noticed. I think I need to write a condition very much like this for gates as well. So now here, we will also add P to J. So first, I do need to check this. So if everything's fine now, if I erase this, oh whoops, I hit Q, okay. If I erase that, now how come that doesn't raise a post condition? Okay, I'm also tired of seeing the simulation logs. I'm also tired of seeing this. And I'm tired of seeing that. And for completeness, we may as well do this. So if I have a gate and I wire something up to it, check this. Net 1, just that. Num ports equals 1. Now if I erase this, it just deletes the net entirely. So that's actually fine. Right, I see. I see why this doesn't apply to gates. So, all right, now let's see if we fix that issue with the junctions. So if I connect a wire to it, so far everything's fine. Now if I erase this, oh, whoops, forgot to put the I pairs. Actually, I don't really need the index, so I can just do this. Okay, connect the wire, now we erase it. Now what do we have? Hey! Okay, so that helps a bit. Now we need to create that other, whoa, oh my god. What is this? What? I think I'm stuck in an infinite loop somewhere. I've never seen that before. Whoa, whoa. Okay. It happened when I tried to erase a junction. What happens if I just erase a junction? What the heck? Erasing a junction puts us in an infinite loop? Check this out. Okay, so why? Why? Why, oh, why, oh, why, oh, why, oh, why? This is one case where I may need to log to a file. I don't like to do that, and the reason is not because I think it's a bad solution. It's actually a better solution than what I'm doing, but I think a lot of the charm of the Pico 8 is in pretending as if you were programming on like a Commodore 64, you know, and it's like, if you hit an infinite loop on the Commodore 64, it's like, you know. Well, anyway, there is a function I think it's print H, maybe, that lets you print to a file on disk. We're like breaking the bounds of the Pico 8, but print a string to the host operating system's console for debugging. If file name is set, append the string to a file in the host. Setting overrides a true cause the file to be overwritten. Set and save to desktop to true, saves to the desktop instead of the current path. Use a file name of @clip directly to the host clipboard. That's interesting. Now, this is something I think I can do this. Let me just do a little quick test to see if this even works. Whoops, what did I just do? For I equals 1 to 100, do, yeah, print H. I'm looking at the documentation on my window, which I'm not showing on the OBS right now. Let's print it to that thing I just made, which is pipe. I have no idea if this will work. Oh, I need this string. Whoops, whoops, whoops. I need to actually print I to pipe. And I know it's not a regular file. Well, that didn't work. That didn't work. Let me see if that even did anything. Oh, pipe.p8l. Fascinating. Oh my god, now we're stuck with Minty. I can't kill it. Maybe I can find it in the list of processes. Oh, it is there. I think if I end task. Oh, hey. All right, well, at least we can do that. What happens if I do... I still can't type in here. Oh, man. STTY sane. Okay. That's a little pro tip there. In my attempts to try and kill less, I was hitting a bunch of control shortcuts, and I know one of them makes it so you can't type on bash. This is just a tip that you should just know it's useful. If you type STTY sane, it'll reset all of the settings for typing on bash. It's just good to know. In fact, another thing you should know is that here I actually typed STTY sane and hit the enter key. But if you do Control J, it's the same as hitting enter, but it's a little bit more reliable because there are ways you can remap enter to do other things. So when your bash is like messed up and you don't know why, you do Control J, STTY sane, Control J. Right, now, what if I do less? What if I go in here? So for whatever reason, it added, so let's do rm pipe. For some reason, it added this p8l on it. So let's move pipe to pipe.p8l. Now we're really going to see pipe.p8l. Now if I go in here, run the same thing. Nothing. Nothing. Let's see what happened. Wow, fascinating. It actually there's two files with the same name, which is a little scary. I gotta kill less again using the task manager. My TTY is messed up again. Control J, STTY sane, Control J, less, ls. Pipe.p8l pipe? What the heck? They have the same name. Oh my god. Wow, weird. So yeah, that's not going to work. It would have worked in Unix, but I'm on Windows, so yeah. The reason I wanted to use a pipe instead of a file is because, well, that's just the right solution. Like, what can I say? But whatever. Let's go in here, and we'll add some print h statements. Actually, I can just do this. I can just do that. Now, let's read through at least the erase square when you get to the junction. So first we remove it from the junctions table. We then get its net. We then do this crazy thing where, that is not the coordinate. I just need to do this. Hey, am I not? Does that not work? Oh. Yeah, but how did... I think through some bizarre twist of fate, I was putting... Oh yeah, of course. Because I was given some garbage thing here as the key, I wasn't changing the fact that the junction was at grid, so it was just looping forever. I mean, however though, my trick to prevent infinite recursion didn't work. Oh, because I had to do it 100 times 100 times. I needed to prevent the infinite recursion here, and then prevent it here. I'm not sure. Yeah, like, anyway, I think it ended up, yeah, I think I see what happened. So let's go back here and get rid of this, because I don't like that. I think it's not cheating, but I think it's kind of betraying the, like, if you're writing stuff on Pico 8, it's not because it's like, it's because you want to have the experience of like what it was like to do stuff in the 80s, back when computers were like accessible to ordinary people. Anyway, so I fixed the infinite recursion. Did I fix everything? It's unlikely. So, you know, let's start playing around with it here and seeing what we can do. I should fix that button P there too. Okay, hold on. Whoops. What? No. Now, what happens if we do something crazy? If I put a junction right here. Okay. Okay, that still works. Now, what happens if we erase something? Well, it deleted my junction, which it was not supposed to do. It actually didn't delete it. It just overrode it with a net, which is not what was supposed to happen. Well, I think we've made progress. Excuse me. So we're definitely in this case where we ran the DFS. DFS returned junctions. I'm aware we haven't tried the abutting junction yet, but you know. Okay, so now if I erase, DFS returns 0 junctions. Okay, well, there's your problem. Why did DFS return 0 junctions? It should not have returned 0 junctions. Oh, do we have neighbor is junction in the log? Neighbor 3 is junction, keep DFSing. Okay, that's right. Add this to the list of junctions. And that didn't do anything. How come that didn't do anything? Oh, I know why. Right. We actually need to give it that argument. I think that'll fix it. Blah, 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 blah. Now we go in here, put one of these. Blah, blah, blah. We'll try the abutting junction in a second here. Okay, now if I erase this. Okay, great. No bad post conditions, so I assume everything's fine. Let's change the log. Okay, this wire on wire is just not giving me anything useful, so let's get rid of that. And let us also get rid of this. And let us also turn the log length back down to 20 because 64 is a little lengthy. All right. Now let's try the abutting junction. Okay, well, my drawing logic is a little I had a physics teacher who would say bass backwards. Yeah, okay, so or maybe I can fix this a different way. It's a little dumb, but you know. Okay, great. I think this is fine. Oh, but okay, well, so now check this out. Okay, so if I go, I don't think there should be any bad post conditions at this point, and there aren't. But now watch what happens, because now that junction, both of its nets are the same. Like all of its ports point to the same net. So if I erase all of this, right, and I erase everything except for that junction, right, go in here. We don't have any bad post conditions. Oh no, this is strange. How did that not break everything? Did I, okay, hold on. I gotta reset it here and see what happens. So now if we do this, we have net 1 with a bunch of stuff, net 2 with just 260. So now if I connect this to that, only one net. Oh. Fascinating. Maybe just by... I was about to say just by luck it works, but actually no, it's because I'm a genius, obviously. That's why it worked. I just don't know. I mean, the fact that I don't know why it works means I'm a huge genius. Well, the fact that it disconnected there is a little concerning, but actually it has done the right thing here of making 2 nets. So because of my genius, I'm such a genius that even I don't understand it. I think what's happening is, let me think about this. We erase this. We do a DFS. So first it does a DFS. I guess it goes this way first. It finds all of this. And because the DFS doesn't hit the junction again, because it marked this grid square as being seen, it ends there. So it makes a net out of all that, and then it searches to the left and makes a net out of just that one part. So I think I'm just going to keep it this way. It's a little strange that it automatically disconnects the other end of the junction. But the only time that the user would see this happening is if they had the junction connected back into itself, which, why would they even do that? So like, if they're doing something weird, they should expect weird results. And although this looks like a weird result, it happens to be correct in that it fixes this problem that I thought we were going to have, but we actually don't. So that's nice. Let me go mark that off. So actually, we did this, and we did that. So now we need to make gates connect automatically. First of all, let's just see if that randomly works. Maybe I'm just a bigger genius than I thought, and maybe it'll just work. So oops, actually no, I don't want that. No, no, no. So now what happens if I put a gate here? Yeah, figured. So no, I will have to place a wire like that to connect it. So, but that should connect it automatically. So I think we can do that pretty easily, because in that logic we already have the special case there for place gate. Auto connect to adjacent neighboring gates junctions. Oh wait, I feel like so. Local pinum, n dot port. Ah, it's this net neighbor thing. Key equals n dot type equals gate and neighbor or net. And I'll mark it as fix me. Fix this stupid net neighbor thing. Oh, is this bad syntax? Why is that bad syntax? I guess you can't just end a line with equals. Okay, no, there's definitely something wrong here. Oh, the string was unclosed. Don't know why that happened. All right, so now, no, let's put on a junction, wire it up over here. Now let's put a gate right next to it. Why did that happen? And we have a bad post condition. Why did that happen? Oh, I see. And yeah, we just need a special case for junctions, don't we? What am I doing here? What is N? What is G? I can't remember. Auto connect it. So N is the neighbor and G is our gate. And not port. Oh. Yeah, we need a special case. We need a special case. Neighbor. Now here, we do the same thing, except now. So the neighbor, which is a junction object, dot port. So we got the right port of it. Now we will do dot net dot I need to add it to the gate list, right? Add gate to nets gate list. Dot neighbor. .net. Whew. So I still need to fix this though. Dot G of G equals true. Could that possibly be the right line of code? And dot port dot. Okay, this is getting ridiculous. Local NN for neighbornet equals this horrific expression. And then, so what is G here? I think we need G dot port of pnum G. So local port equals this expression. In fact, let's call it G port. We could do the same thing up here, but whatever. Let's see what this does for us. Put down a junction, put down some wires, put down a gate. I think that's it. I think that's it. Yeah? Did we do it? Did we finally implement junctions? The thing that's been killing me for like 5 days? I think we did. I mean, there might still be some latent bugs laying around that I don't know about. But I think we did it. I think we did it. Let me check the post conditions. Post conditions look good. I think the performance looks pretty good. The performance looks really good, actually. That's cool. If I scroll the gates off the screen, the performance gets better. That's really cool. So I think we have good performance. That seems to be mostly working. All right, let's think about what to do next. Now that I did this big thing that's been weighing on my mind, I suddenly feel a lot more, like, how do you put it? It's like instead of like gravelly mud flowing through a pipe slowly, it's like water flowing through a pipe. So now, like, there is one thing that I didn't put in this list here, which is delay elements, which might be pretty easy, possibly, maybe. Who knows? Save and load support would be nice. That shouldn't be, well, saving is easy. That's not a big deal. The deserializing, though, is definitely a challenge. Because the DFS function I have right now, it does check like the objects, whereas the deserialization function I need for loading, it just looks at the tile ID and has to build the objects as it goes. So yeah, that will be a challenge, but luckily it's a very, very self-contained challenge in the sense that once I write that the serializer is very easy. All I need to do is inside my draw grid here, implement this full thing, which is currently not implemented, so that it instead of just going 0 to 15, it'll go 0 to the whole size of the map and 0 to the whole size of the map. And then at the very end, we can C-store the map. So saving is like dead simple. On the other hand, though, deserializing is not that simple. Okay, so delay elements, let me think about how that would be implemented for a second. Like, is there a way to do it without writing as much code and with hurting my head as much as I just did when it came to junctions? So a delay element is essentially a gate with a different calculation, and it doesn't have 4 ports. No, that's not true. It does have 4 ports. So yeah, a delay element is just a gate with a different calculation function. I mean, I was always going to need to have a custom draw case for it, and that's going to be true of whatever element I create. Yeah, Uh, yeah. You know, one thing I would really like, I said this before, I already said a couple of times before, gates always face to the right. I'm never going to change that. But wouldn't it be nice if they could face to the left? Wouldn't that be nice? It would be so nice. I mean, so. Oh, no, no, no. I was just about to say in the sprite table you can set flags, but like some of my not gates would be facing right, some of them would be facing left. Okay, well, before I go crazy here, uh, let's quickly take a look at the music just for kicks. Just for kicks. What time is it? Oh my goodness, it's past 9. How do you do this again? Oh, that's cool. Oh my god. This is so wrong. This here? What is that? A sharp 2? Was that number 11? Ah, it sounds. I can't believe that sounded right to me before. How did that ever sound right to me? Oh, it's so wrong. Oh, it's so bad. Man. Okay, well, and I'm just goofing around there. We will fix that. We'll fix it. Um, the delay elements, I don't expect it to be as bad as implementing junctions. The junctions was a real headache, but I think it's mostly working now. There's some other things that we really need. Like it would be nice if there was buttons you could push, like in Logisim. Like that. I mean, Logisim is one of the best pieces of software I've ever used. Like I've drawn whole CPUs in there, like custom CPUs that ran a custom instruction set and everything. Logisim is awesome. Yeah, but so yeah, I don't feel bad at all stealing stuff from Logisim. Well, forget Logisim. I mean, even Minecraft, you can stick down a redstone torch or a button or something, and it's nicer than. Well, come to think of it, it's not really any nicer. It's exactly the same as fiddling with with the elements. But yeah. But yeah, having custom or not custom, but having specific like input buttons, so you don't have to like rewire gates or something if you want to force a 1 somewhere. That would be nice. Yeah. Now, actually, the nice thing is that these custom inputs and outputs, I mean, I'll need a special tool, like, because in Logisim, the finger tool is separate from, like, the wiring tool and all that. But even the input elements, the output elements, they're basically exactly the same as the gates in the sense that, you know, they have ports and, yeah. So, okay, oh, copying and pasting, that would be nice too. That thing about toggling, oh, I may not do that. Control sin speed, oh, that's another thing that has to happen. Oh boy. Oh, okay, register elements, that is what I called them. Yeah, calling them register elements is a little bit better, because right now, like, a gate is a delay element too. I/O components, I definitely want to put I/O components. I'll probably do that before save and load support. So here's the thing. On Monday, I am going away for a week. I won't be at my computer. I won't even have a computer. And I need to make sure that on Monday this project is in a state that makes it easy for me to come back to it a week later. But there's nothing really specific I can do to make that happen. The only thing I could do to make it easy to come back to would be to finish it, which is not happening before Monday. Well, maybe it is if I devote the whole weekend to it, but I can't because I got to get ready for this trip. Anyway, let's focus on the simulator again. I mean, this is pretty much everything I've been thinking. Well, I mean, so what else do I have in the random thoughts here? Try to rewrite placegate as place component. Oh, I already did that actually. When doing driver phase of simulation, how do we update the junction objects? Long story, but I did that. How do we manage the link from junctions to nets? Extremely long story, but I did that. Each net has components list, includes gates and registers and whatever else I add. Yeah, I'm doing that. Each net has a separate list of junctions. We carefully maintain this link relationship. Oh yeah. And then add special case for junctions in DFS. Yep, we did that. So we're out of random thoughts. Ultimately, bottom line is this: any components will merge them into the gate code path. Yeah, other stuff. We need things that circuit controls have challenges. We really need an oh my goodness, we do really need an undo stack. Multi-bit buses, that would be nice too. Like in Logisim, how you have the splitters and stuff. What to do for music? Yeah, I mean the Django Mahjong OST would actually be pretty good. It would be almost ideal, but I'm having more fun with Cirrus, so I'm going to stick to it. I may as well leave this sim loop in for reference. This is, and then these are just like old things that I'm keeping around until I am sure that I can get rid of them. All right, since it's getting late and I'm starting to lose focus, the last thing I'll do will be to try and fix at least that one A sharp there to be the correct note. So let's change the OBS. I definitely don't want to get copyright stricken, so let's turn the speed down. That actually, I should check if I did get a copyright strike on that last one. 1 second. Uh-oh. I think, uh-oh. Oh no. Oh wait. Oh no. Oh, I got hit. I got hit by the copyright claim. Oh, but it's not. Man, what the heck? Okay, a long time ago, I was doing a stream. It wasn't public or anything. It was just because I use the YouTube streaming to record little projects and stuff. Like I actually have like, I don't know, close to 50 hours worth of streams I've done, just to like archive projects that I'm working on. It's actually pretty rare that I make them public, although this one I decided to make public for whatever reason. Anyway, one time I was doing that, like one of the very first ones I did, I was reverse engineering an NES game, like by annotating the assembly. And I was really having fun with that actually. But then like on one day I was making really a lot of progress, a lot of really interesting things. And I got hit by a copyright strike on it for some like random song. Like I was just listening to like an automatic playlist, but it's not like I was playing friggin', I don't know, the Beatles or something. Like I was playing just like random bits and bobs and of like smaller artists. And just this one obscure track that probably has like 1,000 views on YouTube or something just like caused YouTube to fire all its cannons, and they actually like deleted the video. Like I can't see it anymore, which is a shame because there was a lot of really interesting stuff in that stream. Like the whole point of me recording these projects is so I can go back and check out interesting things. So I was really ticked off about that. Anyway, I did get ticked or dinged for copyright, but for whatever reason, Cirrus is actually not one of the ones, despite the fact that it's a huge song, but it's not one of the ones that causes YouTube to like vaporize your stream. So I guess we're okay. But now, I guess, so that little trick I did of changing the speed and the fact that I'm like talking over it and stopping and starting it does help. That copyright claim is only in like a small section of the video, and let me take a look at that again. It's between 1 minute 29 and 1 minute 30. Oh, well, actually, because there is a rule about how like you're allowed to use like 15 seconds of something, but that's definitely more than 15 seconds, so yeah. Anyway, let's change my OBS here. Yeah. And let's fix this. See if we can figure out what pitch that is. How is that not B flat? It sounds like B flat. Is that a D? Telling me that's not a B flat? How can that not be a B flat? I mean, but how can it be when it sounds so wrong? I don't understand. that not be a B flat? I don't understand. How is it right and wrong? What am I missing? Please, somebody who is good at this, like, throw me a bone. I'm so stuck. I remember now why I couldn't make progress on this the other day. I don't understand. Tips for audio transcription. Know your client needs. I'm the client and I need to get the right note. Get out of here. Oh no, this is, I need music transcription. Blah, 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 blah. Blah, 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 blah. Stupid modals. But this isn't helpful. This doesn't help at all. Stupid. I don't understand. I don't understand. It sounds so much like a B flat. How can it not be a B flat? I mean, maybe my other notes are wrong. But I don't understand because when I first started playing this, without having heard the video in a while, right? I played this and I was like, yeah, that sounds right, that sounds right, yeah, it looks good. And then I got here and I was like, no, there's no way that's right, this sounds terrible. But now that I've heard the video, now this sounds right again. I don't understand. I don't understand. I'm just not cut out for this. I don't get it. Maybe, all right, what if I try playing it an octave lower? What does that do for me? Change it here too. Okay. But now that sounds okay. I don't understand. I don't understand. So maybe, I think I've learned something. I think the right note in the wrong octave can sound really bad. Strange. Because I've done music theory. I take piano lessons, which reminds me I haven't practiced piano yet today. Oh, I'll do it before I go to bed. Anyway, though, I've done music theory, right? And what music theory tells you is that when you're playing a chord, or you're just playing multiple notes at the same time, no matter what octave you play a note in, it still forms the same chord. Although it obviously sounds different, it is, in a way, equivalent. But now I'm discovering that the right note in the wrong octave can sound terrible somehow. Why is that? How is that possible? Also, I have another problem, which is that over here, so you hear this number 12 here. Let me play it. That really gives a lot of feeling, or like a lot of like movement or rhythm. Right? So it's like, but when we get to here, because I ran out of voices, I had to cut back a bit, and it just sounds really empty. It's just. So we're missing, and not to mention that I'm already missing like a lot of little, bleeps and bloops that, I just didn't put in because I've only got so much to work with here. But, all right, let's hear it one more time from the beginning before I stop for today. I think I need to maybe change the instrument on this voice 12. Well, that's a result. So let's commit this and stop for today because I still need to eat and practice piano and not go to bed too late so I'm not a zombie at work tomorrow, and then I gotta get ready for this trip, and oh my god, it never ends, but So tidy up, to do, and maybe fix Cirrus. Wait. Oh, I get it. Because I deleted a lot of lines of comments. I was about to say, like, there should be more than 4 insertions. Oh, no. Oh, that's right, because that's right, because the sound effects are all on, like, yeah, like if I do, the sound effects are all on, like, these lines here, like that, so. All right, as much as I would like to keep working on this, I cannot. And that is a shame.